In this next video, I want to talk about our next type of series where we can compute the value of the series exactly. And these are telescoping series. So let's start with an example. The sum from n equals 1 to infinity of 1 over n times n plus 1. So what does that look like? It's helpful to write down the first few terms. We have for n equals 1, 1 over 1 times 2, plus 1 over 2 times 3, plus 1 over 3 times 4, and so on. This goes on forever. And the idea for how to compute the sum of this rational function is going to be very similar to how we would integrate a function like 1 over x times x plus 1. We're going to use partial fractions. So what does that mean? Well, the method of partial fractions says that we can rewrite 1 over n times n plus 1 as a over n plus b over n plus 1. How do we find a and b? We put everything over a common denominator, which will be n times n plus 1. So now we have two rational functions with the same denominator, so their numerators have to be equal. So 0 times n plus 1 equals a plus b times n plus a, which means the only way for this to be true for all n is if the n coefficients match up, if 0 equals a plus b, and the constant coefficients match up, 1 equals a. So, okay, if a equals 1 and a plus b equals 0, then this means that b equals minus 1. So we can check that this works, that 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1. So now we're going to rewrite our series as a sum from n equals 1 to infinity of 1 over n minus 1 over n plus 1. It helps to write out the first few terms to see what's going on. We have 1 over 1 minus 1 over 2, plus 1 over 2 minus 1 over 3, plus 1 over 3 minus 1 over 4, plus 1 over 4 minus 1 over 5. And we can see that we get all this cancellation. This minus 1/2 cancels with this plus 1/2. This minus 1/3 cancels with this plus 1/3. Minus 1/4 plus 1/4. Minus 1/5 plus 1/5. The only thing that never cancels is the initial 1 over 1. So this series is equal to 1. I'm not sure exactly why it's called a telescoping series. It's kind of like you have one term and you're subtracting another term, and then it cancels, and then it cancels, and then it cancels, and it cancels. And you're looking further and further down, and it's, I don't know, maybe it kind of looks like a telescope. I don't know, but that's the idea. We're going to take a rational function, rewrite it using partial fractions, and we get all this cancellation so that this sum of infinitely many terms that we started with, there's only finitely many things that don't cancel. So I'll pause, and then we'll look at a more complicated example, and that'll be the end of this video. Let's look at the sum from n equals 1 to infinity of 1 over n times n plus 3. So we get 1 over 1 times 4, plus 1 over 2 times 5, plus 1 over 3 times 6, and so on. And again, our idea is to apply the method of partial fractions to rewrite the rational function that we're adding up. We know that 1 over n times n plus 3 can be written as a over n plus b over n plus 3 for unique values of a and b. We put everything over a common denominator, and then we see that the numerators have to be equal. So what we get is 0n plus 1 equals a plus b n plus 3a. So that means that 0 equals a plus b, and 1 equals 3a. So a equals 1/3, and b equals -1/3. So that means that the series that we started with is equal to the series 1 over 3n minus 1 over 3n plus 3. It's a little better if we factor out this 1/3. It's a little easier to see what's going on. If this series converges, then we can factor out this 1/3, and what it converges to will be 1/3 times the series that we get by taking a sum from n equals 1 to infinity of 1 over n minus 1 over n plus 3. So now we can start seeing what we get. We get 1 over 1 minus 1 over 4 plus 1 over 2 minus 1 over 5 plus 1 over 3 minus 1 over 6 plus 1 over 4 minus 1 over 7 plus 1 over 5 minus 1 over 8, and so on. So what happens is this minus 1/4, 3 terms later, cancels with a plus 1/4. This minus 1/5 cancels 1, 2, 3 terms later with a plus 1/5. This minus 1/6 cancels 3 terms later with a plus 1/6. And the only things that never cancel are, we get 1/3. This 1 never cancels with anything because the denominator 1 is never equal to n plus 3 for any n from 1 to infinity. So 1 over 1 never cancels. And this 1 over 2 never cancels because there's no n that makes n plus 3 equal to 2 when n goes from 1 to infinity. And this 1/3 also never cancels for the same reason. So this is a perfectly fine answer, but you can put everything over a common denominator. Rewrite this as 6 over 6 plus 3 over 6 plus 2 over 6. And what we get is 2 plus 3 plus 6 is 11. So we get 11 over 18. So what's the big idea here? The idea is when you're taking a series where the sequence you're adding is given by a rational function, you apply partial fractions to rewrite that rational function. And if you're very lucky, now you get a ton of cancellation. And the series that you were adding up before, you were adding up infinitely many things, but there's only finitely many that don't cancel out. So let me point out, this doesn't work for every expression like this. Maybe you apply partial fractions and you just don't get that much cancellation. Maybe you get something where you have like a equals 1 and b equals 1, and nothing ever cancels. But in special cases, we get so much cancellation that our infinite sum turns into a finite sum, and we're able to write down the value of this series exactly.